Okay, so we are off and running here, starting the year with Unit 0, Section 1, What is Physical Science and How do Scientists Think? We're going to start that off by talking about observations. Just like everyday people, scientists make observations. Observations means using one or more of your senses to gather information such as sight, smell, hearing, touch, or taste. In science, we call these observations data, or sometimes we call them evidence. There are two kinds of observations that you can make. First one is quantitative observation. Second one, qualitative observations. Quantitative observations are measurements that involve numbers. The term even sounds like the word quantity, which is what we see every time we shop online. When you add an item to your shopping cart, the seller asks you for the quantity you would like. When you go to the doctor for a physical, you are measured for your height and weight, or they take your temperature when you are sick. These all involve numbers. And actually, if you look at this Funko Pop advertisement, there are many quantitative measurements here. You have 5,319 ratings. You have 27 answered questions. It cost $8.99. It's 3.75 inches tall. And then they give you the dimensions, probably for the box or whatever, that it's 2.5 by 2.5 by 3.75 inches. So there's a lot of quantitative measurements, our observations right there. Now, qualitative observations, these are things that describe qualities of whatever you're looking at. So these are observations that do not involve numbers or measurements. When you bake cookies, you might say that cookies taste sweet, or they are warm, or that they smell like chocolate. These adjectives just describe the cookie, but do not have a number in the measurement. Now, if we go back to the Funko Pop and look at it, we see in here, let's see, do we have any qualitative observations here? It's vinyl. That really doesn't have a number in it. Let's just see, do we have anything else? I've seen other ones where they sell like plush dolls or whatever, Hello Kitty stuff, and they'll say it's velvety red and it's this, that, if it's fluffy, things like that have no numbers. Those are your qualitative observations, and the quantitative observations are the ones with the numbers. Next, we're going to talk about inferring and predicting. These are two things that get a little confusing, so pay close attention here. Inferring happens if you observe something and then try to explain what is happening based on what you already know. That's what making an inference is. For example, if you come home from school and you smell chocolate coming from the kitchen, you can infer that someone is baking something, probably cookies, maybe brownies. Or if you go to the store late at night and see an empty parking lot, you might infer that the store is closed, because normally you would see cars there and now you see no cars there. So when you try and explain something based on what you already know, that is what an inference is. A prediction is a forecast of what is going to happen. So an inference is kind of in the here and now. I see this and I'm going to explain it. A prediction is something that is going to happen based on your data or your experience. So we say here, once a scientist has made their observations and tried to infer what's going on, they can make a prediction. Prediction is when you try to determine what will happen in the future based on data and prior knowledge. Sometimes predictions are called forecasts. This might sound like a term that weather people use on the news, and that's because the weather forecast is a prediction based on data gathered by weather stations and prior knowledge of how weather patterns affect an area. So the important thing here, though, is that you have evidence to back up your prediction. You have experience, or you have, data you've collected. If you predict something with no evidence, that's what we call guessing. Okay, so we just take a moment here to summarize before we move on to measuring. So scientists use the skills of observing, inferring, and predicting. We said that when they observe, they can either make quantitative observations, which have numbers. They can make qualitative observations, which do not have numbers. If they're explaining something that's happening right now, using what they know, then they're inferring. And if they want to then take what they've learned and apply it to the future, in a future scenario, then that is called predicting. Okay, Now we can talk about measuring, which is not a great topic, but we'll just cover it quickly. Since the common system of measurements is sometimes confusing, the one we use in America mainly, you have 12 inches in a foot, 3 feet in a yard, 1,760 yards in a mile, 5,280 feet in a mile, all these crazy measurements, and everything's in fractions. I don't know about you guys, but trying to figure out what socket fits on a bolt if it's not a half and it's not 3/4, all the fractions in between those can be a pain in the neck. Whereas the French created a system in which everything is based in tens, and it's decimalized instead of fractions. So it's 2, 2.1, 2.2, 2.3, 2.4, and so on. It just makes it really easy. And the French get credit for this because they invited the British to join in and help develop the system, and the British ignored them. So that's why it's French. That's why you sometimes will hear it called the international system, or the Système International, what they call it in French. So we're going to talk about the metric system. And when you look at basing everything on the number 10, it makes converting really simple. For example, you can take the meter, which the meter is a very specific length. It has something to do with geography and the distance between the North Pole and the equator or something like that, and they divided up by like 10 million or whatever. And they came up with this standard length that they called the meter. And then they can break the meter up into 10 equal pieces, and those are decimeters. And then the decimeter can break into 10 equal pieces, and those are centimeters. So you have 10 centimeters in a decimeter. You have 10 decimeters in a meter. So 10 times 10 is 100. So you have 100 centimeters in a meter. And if that's too confusing, because that can get confusing, you can think of it this way. How many years are there in a century? 100 years. So centi, that prefix, means 100. Millennium is 1,000 years. So millis are thousands. So there's 1,000 millimeters in a meter. There's 100 centimeters in a meter. There's 10 decimeters in a meter. Decade. Decade's got 10 years in it. See how easy this is? The metric system just makes it real simple. And then rather than having all these confusing inch, foot, yard, mile, league, all these crazy things, everything is just meters. And you just add these prefixes to it. Kilometer, centimeter, millimeter. It just makes it a lot easier. Okay, so here we have some common prefixes that we hear. Actually, 30, 40 years ago, these would not have been that common, but now with computers, these are much more common. So it says here, for length, meters are abbreviated with a lowercase m. For volume, liters are abbreviated with an uppercase L. So when we talk about volumes for liquids, we'll deal with capital L. When we deal with length for meters, we'll deal with a lowercase m. And for mass, because we deal with mass and not weight in the metric system, we will deal with a lowercase g. So here are some of the common prefixes you can put in front of these. Tera, which means 1 trillion. So you probably see computers now and external hard drives that are 1 and 2 terabytes in size. That means that they have 1 trillion bytes of space on them to store stuff. Giga is the more common one. Your phones are 32 gig and 64 gig and 128 gig and all that. Giga is 1 billion. Mega is 1 million. So if you have songs you've downloaded onto your computer on your phone, those songs are usually measured in megabytes because they'll have millions of bytes in them. And then the more day-to-day ones outside of electronics, we have kilo. So we talk about a kilogram, or centi and milli. And actually, I took a picture of a Pop-Tart box nutritional information just to show you that we already do have things in the metric system here in America. They've just snuck their way in here. So there's 10 grams of fat in the Pop-Tart. 3.5 grams of that fat is saturated fat. I guess that's bad. But when you come to cholesterol, there's no cholesterol in them. And the amounts that they deal with in cholesterol and sodium, how much salt is in a Pop-Tart, there's 360 milligrams of salt. So that's 360 thousandths of a gram, or 16% of your daily allotment. Maybe that's why there's so much sugar, 24 grams of sugar in a Pop-Tart, to cover up for some of that salt that's in there. And the salt is probably there as a preservative. So you have grams of protein, grams of sugars, a little bit of fiber in there in grams. Your total carbohydrate count, one Pop-Tart, I guess, is 25% of your daily carbohydrate intake. But your sodium is measured in milligrams. So we do have these things in our day-to-day life. All right, so while we're talking about measurements in the metric system and that, I do need to point out, if you're going to measure something with a ruler, you want to be careful to look at where the lines actually are on the ruler. Centimeters and inches do not fit together nicely. So if on one side of the ruler they want it to be 1 foot, and on the other side they want the centimeters to be 30 centimeters, those aren't going to line up exactly. So you end up with some extra plastic on the edge, because 12 inches is a little bit bigger than 30 centimeters. So just be careful when you're measuring that you actually line it up with the zero line. So we want to use, in science, everybody uses the metric system, and that just makes things easier to send internationally, especially in today's day and age where we have a space program where we work internationally with all these other countries to send things up to the space station and astronauts from other countries and all that. So we're going to use the metric system. So we're going to want to use the metric side of the ruler as much as possible. So when you look at then, again, this breakdown of tens, this purple ruler has centimeters on the metric side. So there's 1 centimeter, 2 centimeters, 3 centimeters at those major lines. And then the minor lines in between them, there's 10 of them. Those are the millimeters. So that's how that breaks down. Just make sure, like I said, make sure that you have it lined up with the zero. So if you look at something, like I have this little line I drew here, and you have to measure the dark line, you want to make sure the bottom of the line is lined up with that zero, and then just count up how many major lines. It's between 4 and 5. So if you look at it, it gets above 4, and then you just count the little lines. It looks like it's about 4.6 centimeters. And we'll write it like that. Even if it was 4.5, we don't want to write 4.5. Half is for the English system. We don't need that. Let's just deal with decimals. 4.5, and this line looks like it's 4.6. So let's see. Yep, that's what it came out to be. So it's 4 major lines and then 6 smaller lines. So we would write that as 4.6 as a decimal and not a fraction. And the last topic in this section is matter and energy. In this course, we're going to use our scientific thinking to study matter, energy, and the changes they undergo. So chemistry, the basic chemistry we'll learn this year, will cover the properties of matter and how matter changes and how every change in matter involves a change in energy. And physics will teach us how matter and energy interact with one another. And we're going to have a lot of fun this year. And if you need to watch this video again, please go ahead and watch it again. And when you're getting ready to study for a test, please come back and rewatch the video, or I will also put the PowerPoint slides in Schoology as well. Thanks for watching.